Hi, I'm Lynn Langett for Teaching Kids Programming, and today we're going to talk about kata questions. To get us started, I want to define what is a code kata. As it says here, code kata is an exercise in programming that helps a programmer hone their skills through practice and repetition. It's basically learning to code by coding. Now, for professional programmers, this is a really common practice, and we have integrated this into teaching kids programming. However, it doesn't appear until the later courses. One of my teachers asked me the question, could we make a small version of katas that starts in the beginning of TKP? So I got inspired. Now, if you want to see what adult katas look like, there's a whole bunch of them over here on katas.softwarecraftsmanship.org. A person named Corey Haynes has done quite a few. There's many out there. And this has to do with fluency. So if you look up fluency, it's really interesting. You actually see reading fluency. Now, of course, we're going to focus on coding fluency, but it's interesting if you look at the definition. Fluency is the ability to read a text accurately, quickly, and with expression. So if you apply that same definition, but if you say fluency is the ability to code requirements accurately, quickly, and with expression, then it becomes sort of interesting. Now, what I've done to enable my teachers to be able to start kids using katas in a more consumable way, because full katas are a little bit much when you're first learning to program, is I started with the first recipe, which you may know, the kids code up a square, and I added what I call a kata question. So let's take a look at what that looks like, and then let's work through how you would teach that. So here we are inside of Eclipse, and you can see that the kids have completed the square recipe. So here is the result of the square recipe, and if I go ahead and run this, you'll see we've got a square. Right now we're going to start with kata questions. So you would normally teach this after you complete teaching the square. So a great way to do it, and I've put these into the solutions up in GitHub as suggestion questions, and you can certainly make your own, but is to ask a simple question. How would you make a triangle in this case? So you'd want the kids to think about that, have them write the steps out in English and translate the steps into code, and make sure to run after each line. Now there's one thing that's missing inside of here, and I wanted to just talk about that because when you're teaching it, there's an additional step that you'll want to take. So you want to think about this process when you're working with the kids in using TKP Kata Questions. The first thing, and you'd find this if you were working with the kids and said, okay, make a triangle, the natural tendency would be not to start coding or writing English, but it would be to draw a picture. And this has to do with the fluency that I talked about earlier, because the most common language for all of us is visual. This comes before we get words. Remember back when we learned to read, we looked at pictures first and then slowly change the pictures into words. And the coding process is the same. So when you are teaching kata questions, the first thing you're going to want to do is to have the kids actually draw a triangle. You can have them do it individually, have them do it on the board, because of course there are different kinds of triangles. There are equilateral triangles, isosceles triangles, right triangles, so on and so forth. So then you want to take that back to the question and refine the question. Most probably the kids will draw a triangle with the same number of sides. We'll just kind of take that example to start with. So then you'd say, how do I make, and let me go back over here, an equilateral triangle, which of course means all the sides are equal. Hopefully I spelled that correctly. So if you look inside of here, then you would then ask the kids, how would you change this code to make this shape that we've drawn? And I'll just refer back to the drawing here. The triangle in the center is, I assume, what they would have drawn. So you want to ask a series of questions to get the kids to examine their code. And you want to say things like, well, what makes a square a square? The kids are probably going to say, well, it has 4 sides. Great. So you want to look over in the code and you want to find the line of code where there's 4 sides. Then you want to think about what else makes a square? Well, it has 4 angles. So now you want to write out the English lines. So you want to write the English lines right here, because we want to make an equilateral triangle. So we want to make a shape with 3 sides, 3 equal sides. And then we want to make a shape with 3 equal angles. All right, now we can see where the sides are, and you want to ask the kids, where are the sides? And then have them move the line of English right up above, because basically they're writing their own comments. So you can see there it is. Okay, and then they can say, all right, we can change that to 3, easy enough, right? And then have them run it, and of course it's not going to work. Why? Because the angles need to be adjusted. Of course, depending on how old your kids are, some might know that the 3 angles, interior angles of a triangle add up to 180, some might not. However, you can do kind of a clever trick here. You can say, what makes the angle? And they're going to probably say the 90. And you can move this line of English down. Now, this becomes a little bit tricky because right now, this is 90. You can do 360 divided by 3 and talk about why that works, because the interior angles are now the appropriate number of degrees. Additionally, if your class is ready for it, you can now talk about refactoring. So you can extract a local variable, and you can call this sides. And now we've got 3 equal sides and 3 equal angles. Of course, the kids could make another kata question. They could say, make a pentagon, and see if that would work. And indeed it does. So this is a nice lead into the variations. You can then go on and have them write out the English steps to change the colors, to change the width, so on and so forth. But what it does is it pushes down to the students the thought process of translating from the shape to the English, to the comments, and putting it in the appropriate location in the code. Now, once you get this set up, you can go a lot more sophisticated. And here's an example. How would you make a right triangle? Now, there's a number of different ways that you can approach this. You have a 90-degree angle, and then you have if you have 2 equal sides, you got 45-degree angles. For the sake of time, I'm just going to skip down and show you what one possible answer is here, and I just refactored it out to a separate method to make it run quicker. And you can see I made a right triangle. Now, there's a number of things here that are great teaching opportunities. First of all, I did a multiplier, and here I did the equal sides. I started with a minus 90 because when you start out, if to draw backwards, let me show you what it looks like, you're going to have to turn backwards, otherwise it's going to go up. So this process of drawing the shape allows you to write the steps out. And it was too small at the 3.5, so I did the multiplier so I could see it. So the minus 90 goes here, the 90 is here. Now the tricky one is here, the 135. We know that this is a 45-degree angle, so why do we need to turn 135? Again, it's the exterior-interior angles consideration. This is from 180, we're turning 135 right here. And again, down here, same thing to get the angle back. So when you're working with the kids, what you would want to do is have them draw this out and then write the steps in English. So turn to the left, basically like this. Turn left 90 degrees, and then so on and so forth. Move the length, and you could multiply it if you wanted to. Now, what's interesting about this example is we have duplication. Now, this is really early in the course, and so you may not want to pull out the duplication because as you get into the course, you'll be doing a number of different refactorings. In Square, of course, you pull out the variable for the sides, but you can see I've pulled out methods and so on and so forth. But it depends on how advanced your students are. You could introduce more refactoring here to get rid of the duplication, to pull up variables, so on and so forth. So this is an introduction to kata questions. I've written them all the way through the courseware, and I'll show you just to give you some other examples. So for example, in high-low, the kata question that I started with is, how would you make sure that the guess, and this is a number game of course, is a positive number? And there are a number of different ways to do that. I have a suggested answer in the variation, which is to use a conditional inside of the for loop so that we're just checking the value of the guess, which is leading again into the variation. This idea of kata questions is a new tool for you to use when you're teaching your kids. I am really interested to hear how working through this process with your students works for you. This is something that as a professional programmer, we're actually doing really frequently. You may or may not know that I work as a cloud and data architect, And one of the big parts of my job is to create an architecture or a picture from which solutions can be built. Creating this kind of foundational thinking when teaching computational thinking, we believe, is key and core to code fluency. So happy teaching, happy coding, and have a great day.